And we are going to shift our gears, not just sort of talking about sort of sun and shadows and insulation, okay? Let's go ahead and actually start talking about the actual energy that this building's using and try to understand really, how much energy each of these different forms might use. So let's go back on over. I'm going to switch back over to my, let's go to low and flat first. Okay, take a look. And I'm going to zoom in on that. Here's what we're going to do. Okay, we want to basically say, hey, even at a high level, this small building of 5 stories, if I told it was a university building and, we can sort of guess how many people might fit in there based on the number of square feet, and we have the climate data, it can actually start making some pretty good assumptions about really how much energy it might use. Now, to guide that, we can tell it a little bit about sort of what the default wall construction is going to be. An important value to give it's the whole notion of really how much glazing is there? What sort of percentage of glazing is there on that surface? Is it 100%, 50%, 20%? And every building type sort of has its own style. Okay? And we can do that for the overall building, or we can even start thinking about adjusting that and customizing it for individual surfaces. So let's go ahead and see how we might do that. We'll zoom in a little closer. So here's the idea. First thing we're going to do is just do something called enabling the energy model. And if you click on that, it's just going to do a little hop, skip, and a jump. Do a little bit of checking in. It's actually adding some information to your model right now. What it's doing is it's kind of taking all those mass floors and it's going to start dividing up the mass floors into what it calls zones, different sort of energy zones. So it could start to think about really, well, just how is the energy actually being used when you're close to a window versus far away from a window. So let's let it regenerate. If you're having trouble, it may be that we need to have yourself logged in. Go ahead and see if that's happening. Let me pop back over here. I'm sort of in a wireframey view right now. That's not too bad, but let me kind of show you what it did. View, orbit. So in a weird way, at a very high level way, this is the way, by default, it's thinking of dividing up your model. Okay, and as a first level assumption, it's probably not too bad. What it's done is it's divided things up into 5 different floors. These are windows based on some percentage that it put in there automatically, and we'll adjust that in just a second. Up here at the top, you're sort of seeing the zones. What's happening here is there is some notion that things that are close to the window behave different thermally than the things that are sort of in the core of the building. And that's typically true, just even in this building. The offices are about 10 or 12 feet deep, and then you sort of hit some sort of interior partition where what's happening in the inner core is a little bit different than what's affected by the window. So it wants us to sort of consider those a little bit separately. And you can choose to turn those zones off or leave them on. It's creating different zones for the east, the south, the corner spaces. There's sort of different interactions. It'll break it up. The bigger your building, the more zones it'll break it up into by default. Okay, but this is kind of the starting point in terms of its assumptions. And it tends to be okay. Let's look at those, sort of where some of those assumptions are coming from. We'll click on energy settings and take a look. So here we have the building type. It's an office building right now. Let's see what other choices we have in there. Police station. Is penitentiary? It is. Well, you can call it a penitentiary or a school or university, either way. Maybe kind of ambiguous. Where these get to used, or really it's the notion of just how many people per square feet are in here and how often we're using the building. So, for example, office buildings that we assume they're being used, 9 to 5 or 8 to 6 or something like that, not so much on weekends. School buildings like universities, we have 24/7 universities. We have some schools which are 8 and 5. There's all sorts of different ways of usage patterns, and this is just sort of some real high-level assumptions about how it's used. Again, you can customize those assumptions, and when you take this actually into Ecotect, you get really precise about the number of operational hours and how many people are in each of the different rooms at different times. Because believe it or not, we actually generate a lot of heat. Even in this building, this one room, it generates an awful lot of heat. You probably figured out. Okay, in terms of, what we want to be looking at, this is, for example, the issue of what the target glazing percentage is. And 40% may be a good overall value. If you want to sort of raise it or lower that, if you want to have a very open building, maybe it's 60% or 70%. If you want to have a relatively more closed-in building, you can lower that percentage. But 40 is kind of an okay overall percentage. I'll show you how to change it on an individual face in just a minute. That'll be more interesting to you. In terms of the windows, too, you sort of give it a target sill height, how high the windows will be off the ground. And based on that, it'll just sort of take 20% of the area in each of the zones and try to make that happen. We're also going to look at the issue of shading in a little bit and sort of whether the glazing is shaded, whether there's any sort of light shelf. We'll turn that on in just a second. Here's the information about the default HVAC system. So a central air handler, hot water heat, some sort of chiller that's running the cooling system. And we can go ahead and change that too. As you start doing building systems design, you can do that. So these are some good high-level assumptions. Okay, and based on this, we can start doing our analysis. Now, if we want to go through and do our analysis or customize the building a little bit, we can do that too. Let me kind of show you how you do that. Here's the deal. As you think about the different surfaces of the building, you know, those east and west surfaces, they got something going on with the sun, but the south facade is often a very special one. It has sort of a different set of characteristics to it. So for any of the surfaces, but often especially paying attention to the southern one, you might want to think about how much glazing is there and whether there's any shading on that glazing to help moderate what's going on with the sun. So even if you go and look at the south side of our building, in fact, you can look at all four sides of the building, and if you really pay attention to the windows, you might notice they're a little bit different on all four sides. They all have slightly different configurations of how deep the window is there a light shelf or a shading feature on it on the window, and also, is that a horizontal surface or is it a vertical surface? So try that at lunchtime. Go just look at the different surfaces of the building, and you may not have noticed it, but all the windows are different based on how they're oriented. Okay, how that actually sort of plays out in this model is, for example, let's go ahead and grab this. Now I can't grab the surface just yet because I'm sort of, what is it? I need to open the model, so I'm going to double click it. And let's see if I can get this. Actually, no. They keep on changing this on me, so let me go back again. Let me finish the mess. What I want to do is actually grab that surface and let it finish. Don't open the model. Ignore what I just told you. Oh, this is so painful to me because it sometimes works and sometimes doesn't. Well, I could do it on that individual surface. Let me do it on that one. Then I'll tell you how to do it on a bigger surface. But basically the idea is if we can choose a surface, you can either use the values by the energy settings, that's the default settings, or if you want to, you can customize it just for that surface. So for example, you can say customize it for that surface, and I can say for that surface, you know, I want to have a special little penthouse there. I want to have 80% glazing in there. Be very, very glassy. Okay, what you do is you sort of get over it and you tab until you can sort of select that surface. That one over there, maybe I want to customize it so it only has, 60%. You could also sort of adjust the target sill height for that surface, and you can turn on a shading feature if you like. So let's talk about that. Since I went through and I put that gigantic window up here at the top floor, which will be nice in terms of getting a lot of daylighting into the building, that might be really bad in terms of all that sun baking people in the room when it's time to air condition things. So what I might want to do there is, let me grab the surface. Turn on something that says the glazing is shaded, and I can put a light shelf or a shading feature in there. Now this is going to look like sort of a big black bar, but it's enough to get us started. As a conceptual model, that's enough to at least shade the windows. Eventually, we'd go off and in Revit, we'd do some nice architectural design and put something interesting in there that looked a little more architecturally fun. But for right now, that's enough just to sort of block the light, enough to get the energy model working. So, yes, yeah.
This is grayed out for me when I try to modify. You know why?
Got it. Can we, let's think about that. Go ahead and say, instead of by energy settings, choose by the custom surface. And now you got it. Okay, so what we just hit there is, let me kind of show you this. When you're choosing an individual surface or even multiple surfaces, for example, if I want to get multiple, let me grab that one, and I can control click and get this one, and I can tab and control click and get that one. So I'm grabbing a bunch. If you have by energy settings turned on, those will be grayed out. But if you turn it on by surface, then you'll have the ability to go through and change those things. So those are all going to be 60%, and I'm going to go through and shade them. Okay, and I'll put 3-foot shades on those. Okay, so you can start articulating the surface of your building a little bit. And again, I don't want you to spend time kind of finely designing what's going on in here, because you'll get to fine design later and really be able to get very accurate results. This is really at a first order of approximation. Tell me about how much window and whether you're thinking of putting any shading feature in there. Okay? And just kind of leave it at that level of detail. So don't make the mistake of thinking you're doing your detailed design yet. This is still, you've done it in the first hour. Okay, so we've put those things in there. We are ready now to go ahead and run an energy analysis on this building and see what's happening. I should do a little more customization, but this is enough to get me started. I'll go to the Analyze tab, and I'll say, Analyze that mass model. And when I do, it'll start communicating with the cloud. It'll ask me in just a second here for a name for my analysis. It's trying to communicate. Let's see if you're doing any better. If you're communicating already and you have already been asked for a name, you can start just typing in a name.
How do you sign in?
Oh, you sign in. It's up here in the corner.
Oh, what is the sign?
Oh, the sign-in name, it's the same name that you use on students.autodesk.com. So if you signed up for an account there to download free software, it's that name. Okay, and if not, say forgot your password. It's probably your stanford.edu address. And then, I'm bad about forgetting my password. So, but that's the one we have to sign in with. Okay, I'm going to go ahead and call this Session 8.1, and I was going to call this Low and Flat. Say Continue. And it's going to send some things off towards conceptual energy analysis, and it's going to go off and cook. What it's actually doing now, it's communicating with some servers back at Autodesk and actually doing the conceptual energy analysis. If you're familiar with doing energy analysis, it's actually using the Green Building Studio engine, which is all based on DOE 2.2 as the calculation and simulation engine. So it's going to go off and just be doing some stuff in the background. It'll let us know when the analysis is done. So that part's good. You don't have to go waiting around, because depending on the complexity of your building, it could take a little while. But we'll let the simulation engine run in the background. Okay, let's go ahead, since the simulation engine is working for us in the background, switch over to a different model, and we'll try analyzing it too. Let's go to tall and skinny. Tall and skinny is always a good one. It's an easy target, because generally the performance of this building is going to be very different than the performance of that building. Let's talk about that even in terms of why that is. When we're thinking about energy analysis, more than anything, you're sort of playing around with this notion of really how efficiently you're encompassing a lot of space relative to the amount of surface area you're creating. So if you have a shape that has an awful lot of surface area that's exposed to the elements, you're really exposed to a lot of heat and sun and weather radiating in and out of your building. So low, flat things, they're not necessarily the most efficient shape. Actually, the most efficient shape, if you can think about it from math, is more like a sphere or a cubic shape, something that's sort of very compact. But how this is sort of compounded a little bit is that of all the different surfaces, the ground is actually considered to be a favorable surface. Okay, because the ground is relatively inert. It happens to hold a temperature which is pretty darn close to our comfort zone almost all the time. So hugging up against the ground is a good thing, okay, as opposed to being exposed up in the air. So quite systematically what happens is tall, skinny shapes like this, which have a lot of surface area and not much ground area, tend not to be very good performers, energy-wise, which is kind of ironic if you think about the way we build most of our cities, because we tend to use a lot of shapes like this. Whereas that low, flat shape, you're going to find out, actually performs a lot better from a building performance standpoint. Now, it's not to say that the sustainability argument is everything, or it's all about energy. Sustainability is much more complex because this happens to be a lot more efficient relative to land use. Okay, as opposed to my low flat buildings, which are taking an awful lot of land and maybe a lot more transportation to get out to them, and kind of, there's other issues. Sustainability is complex. It's not all energy. But from an energy standpoint, yeah, that's not strictly the best shape of a building. So let's go ahead and analyze this one too. I could go through and change the percentages or leave them default. Energy settings. The defaults are hanging around in here. We could change any of those if we want to. I'll kind of leave it about the same so that we're, kind of some normalization between the different shapes. If I want to have a really fair comparison, maybe I should go through and change some of these so they also have the custom shading on this side. So I will, what am I going to do? I'm going to say every other floor on this side has some. Well, that's interesting. I got the roof too. That's what it's not complaining. That's why it's not liking me up there. I'm getting zones mixed in. I want the surface. I'm getting zones. Oh, that's because I'm showing mass zones. Okay, watch out for this. There's this little tab up here, which is, are you showing the outside form? Are you showing the mass surfaces of the zones? I kept on selecting zones because I was showing the zones, which are those regions where we compute those different uses and like kind of for heating and cooling. I'm going to switch to surfaces, and now I can go and get those surfaces. So watch out for that one because it's an easy one to fall into. So I'm grabbing some surfaces. I will change them so they're custom. Say, oh, those are going to be 80% surfaces. But I'll put some light shields in there. I'll put some shading features on that. Let's shade it. Oh, 3 feet deep. Maybe 4 feet deep. Say okay. Let's go ahead now, and with that one set up, say analyze that energy model. And again, it's going to ask me for a name, and it's going to send it off to the cloud somewhere and hopefully do some good work. Okay, this is going to be session 8-1, tall and skinny. Yes?
When you select the percentage of glazing, how does it know where to put it?
It uses what the default sill height is, and above that just sort of does it as a percentage. So it says if all the area above that sill height is supposed to be 30%, it just tries to wedge it in there, and leave an even border around the edges. So it's pretty imprecise. The truth is, it doesn't matter a whole lot. In terms, the percentage is the percentage, and it'll matter eventually, but at the level of approximation we're doing it now, just the percentage is probably enough, because it really, even in terms of what it does, it just sort of says there's a certain amount of surface area that has one transmittance coefficient versus another one. And I guess the biggest thing for us relative to the windows is really how the sunlight's hitting it. But in a lot of ways, if you put a shading feature, it'll put it right at the top of the window. So one thing we can't do that we do in this building, for example, is we have a shading feature that's halfway through the window. To do that, we'd actually have to do a more detailed analysis and do it in Ecotect. Okay, but that'll get started. Has anyone actually gotten the results back yet? Some of you have? Excellent. Let's go see. I'm not sure if I got any back yet. I'm going to go to results and compare. Take a look. And what I can do is, I'm still working. So, alas. I'm at 62% and 30. It doesn't like me as much as it likes you. Either you have a better internet connection or something like that. It's working. Let me just let it kind of keep on working. It's probably working pretty good since we're all doing things together. Let me open up an example of one that I did yesterday. Show you just what's in the results. Oh, I actually have it open right now. This is a result. It's actually produced out of Green Building Studio. Let's take a look at what it is. In the report, it'll show us things like, okay, what the location is, how many square feet we created, what the average lighting power, how many people it thinks it could fit in there, what the electricity and fuel cost is based on sort of local utilities. It'll give us a figure called the energy use intensity. And the energy use intensity, for lack of any other measure, is a really good way of looking at your buildings. This is really how much energy are you using to heat and cool and provide all the loads per square foot. So normalizing everything else, just how much per square foot of usable area that you're creating are you using. And that's actually a pretty good measure. Yeah, at a high level, we could talk about our buildings just in terms of our EUIs and compare them at that level and get some sense of where it is. It's going to have the life cycle energy cost. That is based on the 30-year projected life cycle for the building, how much energy, how many therms and how many kilowatt hours, and what the cost is going to be, again, based on utility rates. So that's a pretty good number. And you'll see that as we look at some different things, using 6.1% discount rate for all you E60 people, engineering economy, we can sort of kind of normalize the dollars and try and figure out really what's going to be worthwhile to do. We have some notion of really how much potential there is in terms of either roof-mounted, photovoltaics, or maybe doing some sort of wind turbines, how much we could actually generate using some alternative or renewable energy sources. And way down in here, we even have this notion of, given the consumption figures and the potential for some net zero measures, what's our carbon footprint going to be? And so far, this building is not net zero. It's about net 299 tons per year. Okay, so that's just one measure of looking at it. So that's how much carbon we're putting into the atmosphere based on doing this building. Now, just to kind of finish up, let me compare that to another building. What I can do is, I had a low and flat one that I did yesterday. It looks kind of very similar to the one we did here. And I can choose those two and do a comparison. And if you compare those two, as it continues to work in the background there, let's take a look. We have the notion at the top level, it's fairly similar. It's all the same location, probably the same number of people. For the energy use efficiency, or intensity, let's see what's happening. For low and flat versus tall and skinny on the right, low and flat's about 59 kilobTUs per square foot. Okay, there it finished. Tall and skinny is about 78. So I'm not sure what the percentage difference is. That's a pretty significant difference between 60 and 78 by just going for low and flat in terms of the overall energy use. If you want to look at it cost-wise, we can say that over the life of these buildings, tall and skinny was going to be 1.78 million or 75 million. Low and flat's going to be about 1.39 million. So that's a pretty sizable dollar difference. Okay, that's dollars that we could be using in other things in our building. Okay, which might be better uses of that money than just sort of expending it as energy. We also have the notion of just the potential for the photovoltaics and things like that. Notice here, this is one thing where tall and skinny really starts losing out, because tall and skinny doesn't have much roof area to go through and put panels on, whereas low and flat has a lot of roof area. So there's a lot more potential there. But the bottom line from a carbon standpoint is something like this. 299 tons per year for tall and skinny, 170 tons per year for low and flat. So carbon impact about half. Not quite half, but pretty close to that, just by changing the shape of the building. So let's go ahead and adjourn there for today and just say that, hey, this whole notion of using tools like this to evaluate your shapes, even, we did these shapes in an hour, stuff like that, to try and understand what the carbon impact is, to try and understand really what's a better shape. Pretty quickly we can use a tool like Vasari to get some good answers, to really just inform your design so you can go on to the next step. But that's really how we want to position this. It's all about just giving you information to kind of keep on going with your design. Yes?
How good are the predictions?
Is that?
How good are the predictions?
Well, they're as good as your assumptions. Okay, so they do use the same DOE 2.2 engine that almost every other simulation package uses. So if the surface areas are right and the glazing percentages are as accurate as you can get them in there, and the assumptions about what type of building, they're as accurate as any other tool. So as eQuest or any other one, provided the assumptions are about right. So you're not losing it on the calculational accuracy side. It's more onto your modeling accuracy. Okay, but you can sort of go to the bank on them. Not quite, but yeah, they're pretty good. Yes.
So could you import a pretty detailed model that you drew in Revit or something?
When we're doing that, it's actually better to go through and the question was, can you import a very detailed model? what we'll do then is, as opposed to coming through this tool, we'll take out of Revit a GBXML file, which is an Exchange format that'll let us go directly to Green Building Studio, which is the mother of what's happening here. Okay, and then we can just do a very detailed analysis down to the mullion and every individual window surface.
Massing models.
Exactly. So think of Vasari very much for quick answers, for quick massing models. Okay, when you do the more detailed modeling, no worries. We'll just take it to a different platform that's using the same assumptions, but it's Green Building Studio. So Vasari is just trying to take all that, what used to be a lot of infrastructure to get the models transferred, and put it into a fairly compact package. So you just click a few buttons and get a quick result. Okay, but it's really the same back end doing the work. Okay, beautiful. Let us go ahead and adjourn for today.